deeply apologize. What do we call it? Factoring trinomials or just trinomials? Trinomials. Which, if you look at, children are nothing more than glorified quadratics. They're actually unglorified quadratics. If I put an equal sign equals 0, it becomes a quadratic. The ones you couldn't do for today, somebody read me one. Stritzel, just give me one of the problems I told you to cross off that has 3 terms in it.
4n squared minus...
Wait, slow down. What? X or n squared?
4n squared
4n squared
minus 72n
minus 72n.
plus 320.
Oh, are you kidding me? Why did you pick minus 72? What's that?
You should say minus 72.
I said minus 72.
Okay. This again, my fault. Here, write this down and firmly ingrain this in your memory banks. Do we have a step number 1? Alright, this is step half. This comes before step number 1. Okay, your first step, always, 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 when you're asked to factor, is to factor out any common factors, which will mean nothing to you until we do this. Put triple exclamation points, because it is one thing that gets forgotten all the time, and I included forgot this. You should have been able to do this. This was my fault. I will take blame on this. That simply means this. Before you do any of that 2 parenthesis thing and what times what gives you this, you look at the 3 terms and you say, can I factor something out of all 3 of them? Do they have a common factor? In which case, what number goes into all 3 of them? Well, you know 2 does, but guess what? 4 goes into all 3 of them as well. So that means you got a reverse distributive property. You put the 4 on the outside, and then in the inside you're left with n squared minus 4 goes into 72 18 times, and 4 goes into 320 80 times. Then you can proceed with the trinomial part that we just did. But you have to remember, in your answer, at the very end when you get those 2 binomials, there will be a 4 outside of it. It's still a factor, and it still needs to go outside there. What times what gives you positive 80 and gives you a negative 18. Again, the only way to get the positive last number is for them both to be positive or both to be negative. I would try Madison. Does 8 and 10, if you have an 8 and a 10, can you get an 18 in some way? Yes. Are they both going to be positive or negative? Negative, because this has to be a negative 18. So you get negative 10, negative 8. I'm sorry, I need a 10 in there, and a 10. And minus 10 and minus 8. Your whole world has changed for the better right now. One more of those. Let me give you one. 4n squared minus 100. Same thing I just talked about. Step half. Can you take something out of both of those? Yes, you can take a 4 out. You are left with an n squared minus 25. Okay. In which case, this is not a 3-term thing, but you sure could make it a 3-term thing. You could go 4 times n squared plus 0 n's minus 25. What times what gives you a negative 25 when added or subtracted together gives you a big old fat nothing in the middle. Maybe. Exactly. N minus 5 times n plus 5. The way to get a negative here is for one to be opposite of each other. By the way, we call this a special case thing. If you see just 2 terms there, one way to get 2 terms is to have the factors be the same number and one negative, one positive. That in fact happens. Perfect. Now, ladies and gentlemen, that you are now completely amazed and excited about factors trinomials, we forge ahead to what might be called a little bit harder than factoring of trinomials. factoring trinomials when the first term is not a 1. This is where, as Cameron Book says, some of you may be left behind. The series. These are a little bit more complex in the fact that this happens. Let me just write problem number 1 down. 7x squared minus 51x plus 14. Okay, step number 1/2, again, even with this, you need, is there a common factor? And there is no, you take 7 out of 14, but you can't take it out of 51, so you gotta do this as is. The difference with this one now is, yes, if you can factor it, you're going to get 2 binomials. The problem is this. Okay, remember step number 1 said what times what gives you the first term? You now are going to end up having numbers in front of your x's here. And this one's not so bad because there is only one way to get 7. How do you get 7? So one of them has to be 7x and one of them has to be x. That will not always be the case. If there was a 6x squared there, you would have a bunch of different ways. You could have a 6 and an x, a 2 and a 3, a 3 and a 2, a 1 and a 6, whatever it is. All right. Now, what makes this a problem, Grace Watson? Why is this a problem? The problem comes, as Grace was just about to say, is that in FOIL, okay, we do our first terms and I got that. But the middle term is a combination of what happens when you multiply this term by this term and this term by that term and add them together. So the thing you have to think ahead of is this. Whatever number you put here is going to get multiplied by 7. Okay? So that means, yes, there's only certain ways to get 14, but whatever number, you know, I've got 7 and 2. Let's just say I have a 7 and a 2 there. If I put the 7 from my 14 here, it's going to get multiplied by this 7 and give me 49 x's. The 2 is going to get multiplied by that 2x there and give me another 2 x's. Do those combine together? Can I get 51 with those? I probably should have done it the other way around. Then you would get it. Yeah, in this case it worked. But if I would have put the 2 here and the 7 here, then 2 times 7 only gives me 14x, and a 7 times x just gives me a 7x. Can I get 51 with a 7 and a 14? No. So you have to think about these combinations here. You have to put the right one with this term so that it gets multiplied by the 7, and the right one with this one to get multiplied by that to give you the thing there. Okay? That's where the whole thing is. Don't worry, I'll do a lot more because I get confused there. Okay? Just remember, yes, the second step is still to figure out what factors of 14 there are, and you don't have many choices, 2 and 7. They're both positive, so it's either positive 2, positive 7, or negative 2, negative 7, or 14 and 1, both positive, both negative. But like I was saying, when you try to figure this out and see which it is, okay, you can't just put these together to get your middle term, because whatever one of those 2 factors gets put out here, in FOIL gets multiplied by this other first term here. So if I put the 2 here, it gets multiplied by the 7. If I put the 7 here, it gets multiplied by the 7. We already figured it out with 7. Let me do another one. Super slow,
Wait, so
because I got really crazy on this.
7x plus.
Don't worry about it. Let's do this one. 3a squared plus 11a minus 42. Here we go. I am going to get you on this first one. Step half. Can you factor anything out of all 3? Negative. Step 1. What times what gives you the first term? Only one way to get 3a squared, and that is what?
3 times 1.
3 times 1. So you can have a 3a and a 1a, but we don't have to put the 1 in front of that. That is the only way to get 3a squared. There's no other factors of 3. 1 is 3. Okay? Now, you got to think of what times what will give you 42. So here we go, let's just break those down. You know it's negative, so one has to be negative, one has to be positive. So let's just do the simple ones first. Negative 6 and positive 7, right? Positive 6 and negative 7, correct? Give me negative 42. What else? 14 and 3. Positive 14, negative 3, or negative 14, positive 3, right? What else? Yes, 42 and 1. Positive 42, negative 1, negative 42, positive 1. Is there another one? Yes, 2 and 21. Your silence is deafening. Do I have another factor of 21? I got it. I got my 2s, my 6s, my 4s, my 7s, my 3s, my 1s. Is there any other 42 factors? 5, 6, 7, 8, 9, 10, 11, 12. You got 7 times 6. I got those. I got my 7s and my 6s. So here is where it gets tough. Stritzel, wake up together. Alright, here is where it gets tough. Remember, whatever factor you put here gets multiplied by this 3. So you can't just go, I want an 11 here, and none of these give me 11. Well, this one actually does. But that isn't going to work, because if I take my negative 3 and my positive 14, and I put my 3 here and my 14 here, my middle term is going to be, I multiply these two together and get a 9a, and these two give me a 14a. Which one did I put? Negative. Let's put positive and negative. That makes this negative and that positive. I get a 5a middle term. Okay. So I try it and I switch it around. What if I made this negative and this positive? Well, 3 times 3 is 9, positive 9, and negative 14 times a is negative 14a. That still gives me a negative 5. It still doesn't work. So now you got to try a different one and flip flop them and put them both. I mean, I can put the 14 here, and I can put the 3 here. Then you got to try the positives and negatives. 14 times 3 is 42. What did I say in the middle? 3 times 8 is 3. Can I get an 11 with a 42 and a 3? No. So you really don't have to do all that, because you can kind of figure out what's close to it. I would probably go with the 6s and 7s. Let me undo all of this. It takes a little bit of thought. So it goes a little quicker than I just did. I just wanted to see that. Oh wait, did I just? No. Okay. So again, the thing to remember is whatever one you put in over here gets multiplied by 3. I want to get an 11, right? And those are pretty close to each other. Let's go with the 6s and the 7s. Okay, if I put a 7 here and a 6 here, my middle term is going to be something that's, I get a 21 and a 6. Can you get an 11 in any combination of 21 and 6? No. So you know 6s and 7s can't go there. So you switch it around and put a 7 and a 6 there. 6 times 3 is? 6 times 3 is? 18. And this one gives you a 7. Can you get an 11 with 18 and 7?
Yes.
Yes. So you know you have the numbers in the right places. You just got to figure out which one's negative, which one's positive. My negative 11, or my 11 needs to be positive. So my 18 needs to be positive. So my 6 needs to be positive, because it was the 6 times the 3 that got you that, and my 7 needs to be negative. So the answer is 3a minus 7 times a plus 6. Voila. Just that easy, kids. Just that easy. 8th graders have been doing this from the time of Jesus, actually before. You know, math has been around, this calculus and this math has been around way before the time of Jesus. Let me go back to the ancient Romans.
Why was it needed?
What's that?
Why was it needed?
It wasn't, just like now, it's not needed, it's just something to teach people. Come on, Logan. Here we go. Number 3, 7b squared minus 62b minus 9. Deep breath, everyone want to know. Again, if you follow the rules, I don't think it's as hard as it seems. First step half, can you take something out of all 3? You cannot. So you know this ends up being 7b and b. Okay? Now it's just a matter of thinking, how many different ways can you break up 9? Well, 3 and 3 and 9 and 1 seem to be my only choices, correct? There's no other way to split up 9. So you need to come up with a negative 62 in the middle. So let me just put my 3's in there. If I put a 3 there and a 3 there, I multiply the outside ones, I get 21b, and I multiply the middle, I get 3b. Is there any way to get 62 with 21 and 3? There's not, so you know it can't be the 3's. So then you've got the 9 and the 1. Well, just for the sake of argument, I am going to put the 1 here and the 9 there. 7 times 1 is 7, and 9 times b is 9. Is there a way to get 62 with 9 and 7? Adding them together. No, but don't forget, I have this here. I can flip-flop these and change and put my 9 over here, because that's going to get multiplied by 7, and my 1 here. 9 times 7 is 63 b's. 1 times b is 1b. Is there a way to get 62 with 63 and 1? So you know you got the 9 and the 1 in the right place, you just have to figure out which one gets the negative, which one gets the positive, because you know one of them has to be there. And which one is going to get the negative? Negative 62 is a big negative, so the 9 gets the negative and the 1 gets the positive. 7b plus 1 times b minus 9. Simply nothing but reverse FOIL. These are pretty much the easy ones I'm giving you because they get harder. I'm going to let you try one. This is all you. Number 4. 5k squared minus 41k plus 42. Somebody tell me you can do that one. So I can do that one. It just takes a little 4 and 5 thought. Just takes a little premeditated. Follow the steps. Answers? You'll make a sigh of relief if you did. Both sides of relief. Oh, that was a gasp. Desperation. There's not that many factors of 42. 6 and 7, 2 and 21. 3 and 14. I got it already. It's not that bad once you start thinking a little bit about it. I always usually take the obvious factors first. I wouldn't use 42 and 1. Just so you know. But you could. Nah. Good spark is much worse than its pipe. Like the old oak tree. You got it, Cecil? Nice. We're all in agreement. By the way, you could put the 5k there if you like, but I try not to. It doesn't really matter. So here we are, remembering we got to get a minus 41k in the middle. I'm going to break down 42, whatever you put here gets multiplied by 5, added to whatever's in there. And I don't know, I would go with 6 and 7 right off the bat. I would probably try my 6 here and my 7 here. 5 and 6 is 30k, and 7 and k is 7k. Do I get 41 with that? No. So then I go back to the drawing board and I'm gonna flip those around because changing the order of them will change what they get multiplied. 7 by and 6 here. 7 and 5 is 35. And 6K, what's going on here? 35 and 6, can I get 41? Yes. Is there a way to get a negative 41 when there's a positive out here? They both have to be negative. So 5K minus 6 and K minus 7 will be your two things. How many people came up, Swiss it? Yes, no, we closed, we know why, is this taxing?
I put 1 is a positive 7.
There we gotta remember, the only way to get a positive at the end and a negative in the middle is for them both to be negative. There's no other way. No other way to get a positive at the end and a negative in the middle. They both have to be negative. You cannot, it just don't work any other way. Just don't. Now, one that might be one for the ages that you have to do step 1/2 for. Let's look at problem 12. 54 n squared minus 162n. I'm not 100% sure, but remind me when you go back there to look to make sure that all of these work, because sometimes they're not factorable, which are, they call prime, but, oh boy, I don't know if I like this one. Step 1/2 says, what can you take something out of all three of them? Yes, at least. You take 4 out of them? No? You take 9 out of them? Anything more than 2? Well, let's take 2 out. If I take a 2 out, I'm left with 27n squared minus 81n minus 30. Now, you always want to check to make sure that something else couldn't be taken out. If you look at this and something can go into all of those, then we didn't take enough out. What can go into all those? A 3. So one way you could do it is this. You can put your 2 here and then put your 3 next to it. And then what do you get left? 9n squared minus 27n minus 10. And this would just become a 6. So this is really what you got to factor, this one here. And there's an unfortunate thing about this. What's the unfortunate thing? Can somebody tell me right now? What's different about this one than anyone we've done so far? Anybody? Oh boy, we just don't think very well. The difference on this one than any other one we've done before is there's more than one way to split up 9. So if you can't, most of you are probably maybe thinking this, that you're going to go 9n and n. But if you can't figure something that works with 9n and n, you would have to also try 3n times 3n. And in which case, I hate to tell you this, whatever number you put here gets multiplied by 3, and whatever number there gets multiplied by 3. I don't know what it is. I'm going to try. Let's try negative 10 and 27 here. Nice thing is 10 only splits up a couple different ways, and I wouldn't go 10 and 1. Let's go 5 and 2. If you put a 2 here and a 5 here, that gives you 5 and 18, correct? Can you get 27, 5, and 18? No. So let me switch those around. Switch those around. What did I put? 5 here, 2 there? 5 there, and wait, did I just do that? Did I just do that one? I did? If I put a 5 here and a 2 there, I get 45 and 2. Can I get it from there? No, so now I'm going to come to my 3's and see if I can't do that. How about a 5 here and a 2 there? 2 and 3 is 6, 3 and 5 is 15. Can I get it there? What if I switch it around? What? Alright, what if I get a 10? Wait. I'm not done yet. Just when you thought all hope was lost, kids. Watch, see, this is something you can tell your kids when you get older. What if, Maggie, what if what? What if my other factor is 10 and 1? 3 times 10 is 30. 1 times 3 is, can I get 27 with 30 and 3? Yep. Which one has to be negative, which one has to be positive? No, the 10 has to be negative, because you need a negative 30 plus 1. So this is that whole thing factored down. Kids, I can't change math, I can only try to get you to love it. And so far,